Okay, this is a lesson on logarithmic properties, and I'm going to go over each property, but you're probably going to want to write them down as I do. First of all, when you have a logarithm, it means that what you're doing is you're finding the power. Okay, so there's two forms of an equation, log form and exponential form. They kind of go together like addition and subtraction, multiplication and division, squaring and square rooting. A logarithm and an exponent go together like that. So if I have this equation, y equals log base a of x, and I want to put that in exponential form, then the base is a, the power is what the log equals, so that'd be y, so a to the y equals x. So basically when you're using a logarithm, you're trying to solve for a power. All right, so here are the properties. Log base b of 1 equals 0. If I put that in exponential form, it would be b to the first power equals 0, which is right. Anything to the first power is 0. Log base b of b is 1. So this would mean b to the 1 equals b. Well, that's also true. So b equals b. B to the x equals b to the x. Shows you that the log base b of b to the x is just going to be x. Anytime these two parts are the same in the logarithm, then the answer is going to be whatever that power is. When you have logarithms with the same base that are added together, so here I have log base b of u and log base b of v, I can change it to a multiplication problem and make it log base b of u times v. So if I have log base 2 of 7 plus log base 2 of 5, that could become log base 2 of 35, because I can multiply the 7 times 5. Subtraction and division go together. And then the last one is when you have a power, so log base b of u to the n power, that n can be put down in front as a coefficient. Okay, so this assignment is just going to be on practicing on expanding logarithms and condensing logarithms using the properties. When a base isn't written, then 10 is implied to be there. It's called a common logarithm. Bases have to be the same in order for these properties to be used and then condensed. So before I can condense the subtraction, I want to make g the power here in this first logarithm. Now I can rewrite it. It's log base 10, but I don't have to write base 10 because it's implied to be there, of a to the g divided by d. So subtraction becomes division. For the second one, addition becomes multiplication. So d times q, oh, I forgot to put the 8 in the power position, times q to the 8th. Subtraction, this first one, becomes division. Log base b of 4 over 4 is actually going to be log base b of 1, which we already know is 0 from the first property, which makes sense. Log base b of 4 minus log base b of 4 gives you 0, so that shows that that's true. The second one is just asking you to make it a power instead of a coefficient. So here I'm asked to expand each logarithm using the properties. So when I have division, it's going to become subtraction. And I could take it one step further and put the 2 out in front. So for the second one, I get that, and then I can put the 3 in front and the 2 in front. Bases just have to be the same. Here's another example, a little bit more complicated, of division becoming subtraction. Oop, I forgot the y. And then the second one, log of y cubed I'm going to change this z, cube root of z to the 4th as z to the 4/3 minus log of x. And then I can expand that further, making this addition. And I can even make 3 the coefficient. Oops, minus log of x. Okay, so there's several steps in expanding. Let's do another expanding one. Log of z squared y minus log x. I'm going to change it to the 5/3, make the root a power. Then I can add and then I can make 2 the coefficient. And 5/3 the coefficient. Okay, so you're going to go to Delta Math, do the expanding and condensing logarithms assignments on log properties. What is this puzzle? 77 years ago. Sorry, you couldn't see all those years. There are 7 of them there. Reach out if you have questions.